Hello students, today we are going to see the normal distribution. Normal distribution, we are all supplied with all the details, that is mean, variance and moment generating function. Every mode are given and we are supposed to calculate the probability density function of the normal distribution. So the formula is f of x is equal to 1 by sigma square root of 2 pi into e power minus x minus mu square divided by 2 sigma square, where x lies between minus infinity to plus infinity and mu lies between minus infinity to plus infinity and sigma greater than 0. And mean is equal to mu, variance is equal to sigma square. The moment generating function is mx of t is equal to e power mu t plus sigma square t square by 2. So this is that normal distribution formulas. So this formula, we have to convert this normal distribution to standard normal distribution, or that is the variable. We have to convert that to normalized variable z, that is x should be converted to normalized variable z. So the formula will be f of z is equal to 1 by 2 square root of pi e power minus z square by 2, where mean is equal to 0, sigma is equal to 1. So in general, the normal distribution is like a bell curve and it is the value of x. So it is placed anywhere in the graph. So we cannot find the probability density function for this variable x, for which we have to standardize the normal distribution. How? This is the method. Step 1 is converting x to z. That is, we are fixing the x value exactly to the mu and making x is equal to 0, y-axis become the symmetrical axis. Which means that the top of the bell curve is on the y-axis and the y-axis split the curve into exactly two symmetrical parts. So now is that we have converted the x value to z, where z is equal to x minus mu by sigma. Therefore, the probability density function of the standard normal distribution is f of z is equal to 1 by square root of 2 pi into e power minus z square by 2. So this is the method derivation we have in the standard normal distribution. Hello students, now we are going to do the example sum. A normal curve has mu is equal to 20, sigma is equal to 10. Find the area between x1 is equal to 15 and x2 is equal to 40. The sum itself, it is denoted as a normal curve. So it is a normal distribution. So area is the probability to be found. So what is the question? We are framing the question as probability of the area x lies between x1 and x2. So we are representing x as the area. So x as the area, so this is that, and we are supplying the values lies between x1 15 to 40. So probability of x, directly we cannot find out the probability for this normal curve. We have to standardize the normal curve to z. So what is the formula for z? Z is equal to x minus mu by sigma. So supplying this value, that is subtracting the mean and dividing by standard deviation sigma, we got. So what we got? So subtracting by mean and dividing by sigma, we will get the standardized normal form. So P of 15 minus mu by sigma less than or equal to x minus mu by sigma less than or equal to 40 minus mu by sigma. This is the process by which we are normalizing the x variable to standardized variable z. So normal form is converted to standardized normal distribution. That is, in the x subtracted with mean and divided by sigma on the entire inequality equation. So supplying the mu value and the sigma value, we will find the values of. So P of x minus mu is we have 20 and the sigma is we have 10. So P of 15 minus 20 by 10 less than or equal to x minus mu by sigma 40 minus 20 by 10. So finally what we have, P of minus 0.5 less than or equal to z less than or equal to 2. We have converted to the standard normal form with the limits minus 0.5 to 0.2. So actually what is the process we have done is the bell curve on the graph is shifted to the y-axis, which is exactly splitting the entire bell curve into symmetrical parts. So symmetrical parts means left side value minus the value between 0 to 0.5 is same as the value between 0 to 0.5. So that is the symmetrical nature, symmetric property. So we have 0, minus 1, plus 1. So in between the value are equal. So if we have 5 means here also it will be 5 points. So that is that symmetric property. So we have that. So this is that minus 0.5 is at less than or equal to 0.2. To use this symmetric property, we are shifting that x variable to z variable by normalization. So now we have 0.5. So how to that? We are splitting. So 0. So minus 0.5 to 0 and then 0 to 0.2. So this splitting is made. According to that symmetric property, minus 0.5 is symmetrically representing the 0.5. So we can go for P of 0 to 0.5. Here already in the positive side, because in the table, normalization table, we have values for positive values. So left side is exactly similar to the right side. So it is converted to 0 to 0.5 and 0 to 0.2. And checking the values we will get in the standard normalization table. 0.5 we find 0.1915 and 0.2 is 0.4772. So the total is, we have the area. The total area is 0.6687. The probability is find out. So this is that finding the area between the two specific points in the normal curve. Dear students, in the normal distribution, we are solving the second sum. The sum is, in a distribution exactly normal, 7% of the items are under 35 and 39% are under 63. What are the mean and the variance? That is a sigma, அது கண்டுபிடிக்கணும் number. So we have to make it as a diagram. So what is the diagram? X value we have 35 and x value, x1 is 35, x2 is 63. So when in that normal distribution, the diagram is, the bell shaped diagram is shifted to the y axis. So minus infinity to plus infinity, that x lies between minus infinity to plus infinity. What is the percentage? When x lies between minus infinity to plus infinity, it is 7%. So when x is 35, the value is under 35 or 7 percentage. So under 35 is 7 percentage. And similarly, when the x is 63, the values are under 89. So this is x6, x is 63, the values are under 89. So up to this at the point 63, the value is 89%. At the point 35, the value is 7%. So related to minus infinity to plus infinity, we have represented in the diagram uh, related to minus infinity and plus infinity. When x is equal to 63, the items are 89 percentage. When the x is equal to 35, related to minus infinity to plus infinity, the items are under 7 percentage. It is represented. Now we cannot perform the standard normal distribution directly when the variable is x. That should be normalized and it is plotted exactly in the x-axis. That is, it should be related to 0. The x lies between minus infinity to plus infinity is given. We have to find out associated to the x is equal to 0, that is plotted to the y-axis. That shifting we have to represent in the diagram. So in a symmetrical manner, the diagram is that y-axis is split the entire area into two similar parts, that is 50% 50%. So when x is equal to 35, associated to the y-axis, that is mu x is equal to 0, how is the remaining portion is find out. So 50 minus 7, 43%. That is the x is related to x is equal to 0, the y-axis. Similarly, now it is already x is equal to 63 is associated with the minus infinity to plus infinity. Now we are going to associate with the x-axis 0. So what is the 60%? Below 60, 89% we have to mark. So from minus infinity to up to this, it is 89% it is given. So similar associating to the axis, it is 50%. So remaining is 39%. So plotting the diagram, the x value associated with the minus infinity is converted to the bell-shaped diagram, that is normal curve associated with the x-axis completely with the mu value. So this is 43% and 39%. So this is done. So when x lies between minus infinity to plus infinity, the items are under 7%. So it is shifted to z value. How? So associated to mu. 35 is x less than mu. So subtracting minus mu by sigma to derive the z value, we are supplying this formula. In the inequality, every term is subtracted by mu and divided by sigma. We will get the area associated with the y-axis. So 35 minus mu by sigma less than x minus mu by sigma less than mu by sigma. Mu minus mu by sigma is 0. So x minus mu by sigma is z, that we knew. So this is we are doing. So 35 minus mu by sigma less than z less than 0 is equal to 43%. So this inequality is shifted to the standard normal form. So here the probability is given, z is given, we have to find out the 35 minus mu sigma. So how to find out the z value? To find out the z value, we have to use this probability. In the standard normal table, the row value and the column value are found, and it is the exact value of the 35 minus mu by sigma. Here as it is less than 0, in the left side portion we are representing it as minus 1.48. So 35 minus mu by sigma is equal to minus 1.48. So this is one equation. We are denoting it as equation 1. Now we have the second part, x is equal to 63. It is associated with minus infinity. We have to associate this with the x is equal to 0, which is equal to mu. So that is associated with the mu, the area is 39%. So it lies between mu greater than x less than 63. Here it is associated with the mu greater than 35 less than mu. This portion is x is less than mu and it is greater than 35. This probability. Here it is probability of mu. Mu x lies between mu, this is that mu and 63. This portion. So this portion is, that is x is greater than 35 and less than mu. This is that mu. Here x is less than 63 and greater than mu. This is that formula. So we are applying it. This 39% we have taken. So in order to convert this x to z, we are subtracting my mean and dividing it by standard deviation in all the items of the inequality. So we are getting p of 0 less than z less than 63 minus mu by sigma is equal to 0.39. Using the standard normalization table, find the z value in the table. For 0.039, the row is 1.2, the column value is 0.03. Summing up, we are getting 1.23. As it is in the positive side, we are having 63 minus mu by sigma is equal to 1.23. This is z value. So this is equation number 2. Solving these two equations, we will get sigma and mu. Thus, this is another sum. When the standard normal form is given, we have to find out the mean and the variance and standard deviation. Thank you.